Hello everyone and welcome back to Mnemonics Science. In this tutorial we're going to be working at the Krebs cycle, also known as the CAC or TAC. The CAC simply stands for the citric acid cycle, while the TAC simply stands for the tricarboxylic acid cycle. Notice that this is one of the most fascinating pathways in biochemistry where energy is extracted from nutrient. It is also used for the synthesis of NADH and the production of amino acid. A very important question is, where does this Krebs cycle actually take place? We can choose to put it differently this time around by using a very simple and short mnemonic by saying MECP. Notice that the M simply stands for the mitochondria. I will show you how it works. While the E simply stands for the eukaryote. The C simply stands for the cytosol, while the P simply stands for the prokaryote. So if you ask where does the actual location happen, you can say this, this Krebs cycle actually happens in the mitochondria of eukaryote, that's number one. And it also occurs in the cytosol of the prokaryote. That's the second part. A lot of people find this Krebs cycle to be a little bit tricky, but right now I'm going to provide you with a very simple, short, and sweet mnemonic that can help you to memorize everything. This is how the mnemonic goes. Feel free to grab your pen and write it down. We're going to start with parents. Father or mother, anyone, a parent. Always order children ice cream and 2 snacks. But the 2 snacks, feel free to write it this way. Since we said it's 2 snacks, let's write the first one snacks and snack for meals. So notice that this parent actually stands for the pyruvate. What is pyruvate? This is simply the 3-carbon molecule, but we are going to look at that later. What about the A? This is the acetyl-CoA. So here we have the order, which is oxaloacetate. And here we have this C, which is the citrate. Here we have another I, which is the isocitrate. And here we have our A, which is the alpha ketoglutarate. Alpha ketoglutarate. And here we have our S, which is succinyl-CoA. So this is supposed to be CoA. Here I made a mistake. And here we have our next snacks, which is the succinate. And the last but not the least, which is the M, and this simply stands for the malate. I'll take a very quick revision on this. We said the mnemonic for us to memorize the step of the Krebs cycle is parent always order children ice cream and snacks and 2 snacks for meals, which is the pyruvate, acetyl-CoA, oxaloacetate, citrate, isocitrate, alpha ketoglutarate, succinyl-CoA, succinate, and fumarate. Then the last but not the least, which we said the malate. So another important question which we need to ask is, what is glycolysis first? The glycolysis is simply the process of breaking down glucose into pyruvate. That pyruvate is very important when it comes to Krebs cycle, because we really need pyruvate because that is the first thing which we need in order to have our complete Krebs cycle. So when glycolysis breaks down, into pyruvate, just simply to release an energy. So do we agree with me if we said the glucose is simply a 6-carbon molecule? when it undergoes the glycolysis, it's split into 2. 6 divided by 2, which is simply going to be 3. And the final product which we are going to get at the end of the glycolysis is the pyruvate. Pyruvate. So meaning that pyruvate is 3 carbon molecule. I would like to keep all these steps as easy as possible by using this mnemonic also, which is PEP. That is what I will be using most. I'm going to talk about the process, enzymes, then the last one is the, what do you call it, the product. We said process, enzymes, and here we have our final product. It's just like the glycolysis, and the final product is the pyruvate. So let's begin. Since the end product of glycolysis is pyruvate, and we said the glucose have 6 carbon molecule which end with pyruvate, which has 3 carbon molecule. So for the Krebs cycle, we really need the pyruvate into the cyclation. So we're going to start with the pyruvate at the first entry point. And remember, in bracket, you put 3 carbon molecules. At this point, the next step is the oxidation of pyruvate into acetyl-CoA by the enzymes pyruvate dehydrogenase. Here we have our, what do you call it, our pyruvate. Remember our mnemonic, I hope you write it down. Pyruvate into acetyl-CoA. With which enzymes? We said the pyruvate dehydrogenase complex. In this reaction, a molecule of carbon dioxide and a molecule of NADH is generated. Notice that initially our pyruvate is 3 carbon molecule, then our acetylcholine is going to be 2 carbon molecule instead of 3. Simply because we lost 1 charges to this carbon dioxide here. So here is going to be 3 carbon molecule, 3 charges for electron actually. The next step is acetyl-CoA, which is this. We'll continue into the cyclation. And it will combine with oxaloacetate. When both of these two combine, they are going to give rise to, remember, here we have 2 carbon molecule, and this oxaloacetate is 4 carbon molecule. 2 plus 4 is simply going to be 6, and they are going to give rise to citrate. Therefore, this citrate is going to be 6 carbon molecule. At this stage, we have seen the process and we have seen the product. The product is the citrate, which has 6 carbon. So then the enzymes will take the name of the product. Therefore, the enzymes is going to be citrate synthase. At this point, the citrate is rearranged into the isocitrate via the intermediate called cis-isonitate. Here, we are going to have a conversion into, from citrate is going to be isocitrate. And notice that this conversion here actually happened with the help of an enzyme aconitase. Let's put it in bracket. This is an enzyme. At this point, the isocitrate will simply undergo oxidation and decarboxylation. When we said decarboxylation, we're basically talking about the release of carbon dioxide. And with the help of an enzyme called, which will help this conversion, isocitrate dehydrogenase. It will take the name isocitrate dehydrogenase. And the final product is going to be alpha ketoglutarate. Notice that at this point, the NAD will simply be reduced to NADH. Remember, this is an enzyme, the one in bracket. Notice that at this point, another decarboxylation will occur, which is releasing carbon dioxide at this point with the help of an enzyme, which is going to be alpha ketoglutarate dehydrogenase complex. Alpha ketoglutarate dehydrogenase complex. And this will give rise to, this is the final product at this point, which is the succinyl CoA. And notice that this has 4 carbon and NADH. Notice that from this step, the succinyl CoA will be converted into the succinate. And at this step, we're going to have the generation of GTP or ATP. With the help of these enzymes, let's write it in green, which is the succinyl CoA synthetase. At this point, the succinate will simply be synthesized into fumarate with the help of an enzyme which is succinate dehydrogenase. Let's write it in short form. Succinate dehydrogenase. And the product is going to produce, here we're going to have FADH2. That is an energy carrier. At this point, water will be added to fumarate, in order to produce what we call the malate. So notice that this conversion will simply happen with the help of an enzyme. This is the enzyme, fumarase. Also keep it in mind that the malate is 4 carbon compound. Let's write 4C in bracket. So the last but not the least, this particular guy which we have here, the malate, will simply be oxidized back into the oxaloacetate, which is this. And remember how we get this combination of oxaloacetate, which is the 4 carbon. They combine together with the acetyl-CoA and give rise to the citrate, which is 6 carbon. So at the same time, we lose, is it 2 oxygen? No, sorry. The acetyl-CoA is a 2 carbon molecule. The oxaloacetate is 4 carbon molecule. 2 plus 4 is simply going to be 6. And this is how we get the 6 carbon molecule on the citrate. So let's take a very quick revision on what we just did. We basically talk about the Krebs cycle, which we said pyruvate is very important, and we drive or obtain our pyruvate from the glycolysis. And we said the pyruvate is basically a 3 carbon molecule. It moves into the circulation and combined with the acetyl-CoA, which is here from 3 carbon molecule, the acetyl-CoA became 2 carbon molecule. We give one of our carbon here to the carbon dioxide with the help of the enzymes, the pyruvate dehydrogenase. Then this acetyl-CoA combined together with the oxaloacetate, they give rise to the citrate. From citrate, it combined to the isocitrate. From isocitrate, alpha ketoglutarate, from there to the succinyl CoA, from succinyl CoA to the succinate. There, fumarate, from fumarate, it became malate. From malate, it goes back into the oxaloacetate. So this is it for this problem. I hope you find it helpful. Please, if you do, just do me a favor by just smashing on the like button and the subscribe button also. Thank you and see you next time. Hello everyone and welcome back to Mnemonics Science. In this tutorial,